the as classes. Gurubhyo Namaha. This is your Murali Krishna. This is the 11th video on real analysis, single variable calculus on chapter functions. In this video, we are going to discuss about the functions, piecewise functions. So the lesson is piecewise function. First of all, what is meant by piecewise function? Let me explain this concept by taking an example. Suppose I have function f of x is equal to, I have x square and 0 less than or equal to x less than or equal to 1. X when 1 less than or equal to x less than or equal to 2. X plus 1 when 2 less than or equal to x less than or equal to 3. This is a function. Now if you observe carefully, the domain of this function, is starting value 0, ending value 3. Okay. Next one, this domain is written as, or you can say this domain 0, 3 is split into 3 parts. Number 1, number 2, number 3. The first one is 0, 3 is first one 0, 1 union 1, 2 union 2, 3. The actual domain is written the union of subsets of real number set. That is number 1. Number 2, the working rule is changing from subset to subset. Then these type of functions are called piecewise functions. Number 1, the domain is the union of subsets of a real number set. For each subset, working rule is different. Then such type of functions are called piecewise functions. This is one. Now if you observe the graph of this function also, between 0 to 1, I'll take 2, I'll take 3 here. Between 0 to 1, the working rule, f of x equal to x square, it's a parabola. So it goes like this. Between 1 to 2, f of x is equal to x, again identity function or straight line equation, straight line. Between 2 to 3, when I put x is equal to 2, here it goes to 3, somewhere here. Next one, when I put 3, 4. So here 0 to 1, one shape, 1 to 2, other shape, and I'll take 2 here. Between 2 to 3, another shape. So here you can find the pieces in the domain. You can find the pieces in the working rule. You can find the pieces in the graph. Such type of functions are called piecewise functions. This category. Number 1, very famous function, absolute value function. Number 2, signum function. Number 3, greatest integer function. Number 4, fractional part function. These are the 4 functions comes under this category. Now I am going to discuss about the definition of each function, domain, graph, range of the function, as well as properties of these functions. One by one we discuss. So the first one is absolute value function. This absolute value function is also called mod function, modulus function. Modulus function. Absolute value, modulus. Okay. First of all, what is the definition of this function? F maps, domain of F2, range of F, defined as f of x is equal to x when x is more than or equal to 0, minus x when x is less than 0. So here my entire domain is divided into 2 parts and 2 types of working rules. Okay. Now how do we denote this function? Okay. In most of the textbooks it is denoted by x between 2 vertical lines and read as modulus of x, or simply mod x. That's all. Okay? Okay. Now, what is the domain? Now, domain, we observe x more than or equal to 0, entire positive real number set, and x less than 0, entire negative real number set. So, all together is real number set. So, my domain is minus infinity to plus infinity, or I can say a real number set. Now, I draw a graph, then I tell you what is the range of this function. Okay. What is the graph of this function? Let me draw the graph here. 0 to x, y, x bar. Now this f of x is equal to x. When x is more than or equal to 0, this is nothing but y is equal to x. Y is equal to x is a straight line which is passing through origin, which makes an angle 45 degrees with the x-axis. So my graph will be like this. This is y is equal to x. The next one we have y is equal to minus x. Y is equal to minus x is also straight line passing through origin, which makes 135 degrees angle with the positive x-axis. That is the graph is like this. So this is 45 and this is 135 degrees. Of course, you can extend up to infinity. This is the graph of the function. Now, if you observe the graph of the function, the graph is never coming down. So it's always above x-axis. Above x-axis means the range starts from 0 and goes to infinity. There from the graph, the range is equal to 0 to infinity, included, excluded, or simply we write r plus in the equation. This take, next we discuss about properties of mod function. It is mod x represents. Mod x means it is the distance of x from the origin. It is the distance of x from the origin. Or I can say mod x is nothing but a distance of x comma 0 or minus x comma 0 from the origin with respect to orbital. That means if I have this one 0 0 and this is x comma 0, this is minus x comma 0, somewhere here. Let's say this is equal to A point and this is A point. Now this distance or this distance will be mod x. So in general, what is the distance formula? Distance formula under root of x minus 0 whole square plus 0 minus 0 whole square, or you get x square. So root x square is nothing but mod x. This is very, very important. So number one, mod x means under root of x square, or root x square is equal to mod x. This is one important point. Second thing is, we have one more way also. My mod x is equal to maximum of minus x comma x. Maximum minus x comma x. Okay, let us find some values. For example, I want to find f of minus 2. For example, I will explain it. F of minus 2 is equal to, or you can say mod of minus 2 is equal to maximum of minus 2 and minus 2. And this is same as 2 comma minus 2, which is equal to 2. Therefore, the f of minus 2 is equal to 2. Suppose if I want to find f of 3, f of 3 is nothing but maximum of 3 comma minus 3, which is equal to plus 3. F of 3 is equal to 3. Okay, if I want to go for f of minus 1, obviously equal to 1. So here the mod of negative number. So it is just the distance of that number from the origin. Because the distance is always positive. So to represent distance in mass, we use this symbol. Okay, now let me do some more properties. I like one by one. So number one, mod x is equal to distance of x comma 0 or minus x comma 0 from the origin. Next one, root of x square is equal to mod x. And second one is mod x is equal to maximum of minus x comma plus x. This is the mod x into y is equal to mod x into mod y. For all x belongs to x comma y belongs to a real number set. Mod x by y. Of course, y is not equal to 0. Mod x by mod y. For all x comma y belongs to R and y is not equal to 0. And moreover, my mod x will be always more than or equal to x. For all x belongs to a real number set. Why? Because even suppose if x is a positive number, mod of positive number is same number. Of course, same number is more than or equal to that number. Next one, if x is negative number, my mod x will be positive, and the positive value is always more than or equal to x. Okay. X one, mod of x plus y is less than or equal to mod x plus mod y, and mod of x minus y also less than or equal to mod x plus mod y, and mod of x minus y is more than or equal to mod x minus mod y whole mod. A is any positive real number. Okay, then mod x less than or equal to a, this implies minus a less than or equal to x less than or equal to a. Whenever you have including symbol, here also you have to include. Or if mod x is simply less than a, then minus a less than x less than a. Okay, the same way, when mod x is more than a or equal to a means my x is less than or equal to minus a, my x is more than or equal to a. Whenever I don't include a, then I have x is simply less than minus a and x is more than a. For all x comma y belongs to real number set, mod of x plus y is less than or equal to mod x plus mod y. Approved. Now consider mod of x plus y whole square. Mod of x plus y whole square I can written as x plus y whole square. It can be written as x plus y whole square because x plus y whole square is also positive. Mod of x plus y whole square also positive. Now I use just normal identity. This is x square plus y square plus 2 times of xy. Now mod x square can be written as mod x whole square and this is mod y whole square plus 2 times of xy. Let this is number 1. Now look here. X and y2 for any two real numbers. For any two numbers x and y. Can I write my product xy is less than or equal to mod of xy? I have proof. Why? We have an identity. Why? Because my mod x is always more than or equal to x for all x. We have one property of this positive real number set. So xy less than or equal to mod xy, or a 2xy is less than or equal to 2 times of xy, or I can write 2xy less than or equal to 2 times of mod x into mod y. Now we know very well, if a is less than or equal to b, if I add a positive quantity on both sides, the inequality won't change. So by adding a positive quantity, value of both sides does not change. Right. So what I do, I add positive quantity on both sides. Add x square plus y square on both sides. If I add, what I'll get? X square plus y square plus 2xy less than or equal to x square plus y square plus 2 times of mod x mod y. And this x square plus y square plus 2xy is nothing but x plus y whole square less than or equal to. I can write this x square as mod x whole square mod y whole square plus 2 times of again mod x into mod y. Therefore, we have x plus y whole square is less than or equal to mod x plus mod y whole square. But x plus y whole square is equal to mod of x plus y whole square. So I can write that one. So this is mod of x plus y whole square less than or equal to mod x plus mod y whole square. Now taking positive square root on both sides, so we get mod x plus y is less than or equal to mod x plus mod y. This is very, very important statement. For all x comma y belongs to R, mod of x minus y is more than or equal to mod x minus mod y, again whole mod. Why? Because both sides positive. Okay, proof. Consider mod x minus y whole square, and this can be written as x minus y whole square, and this is nothing but x square plus y square minus 2xy. Therefore, mod of x minus y whole square equal to, I can write x square as mod x whole square, I can write y square as mod y whole square. Of course, the 2xy as is. That is number 1. Now I'm going to use same identity which I used in the previous one. Look here, for all, we know that for all x comma y, xy is less than or equal to mod x. Okay, so xy is less than or equal to mod x times mod y, or minus xy is more than or equal to minus mod x minus mod y. When I multiply both sides negative sign, inequality will change. Or 2xy is more than or equal to 2 times of mod x mod y. Number 2. Now I am going to use 2 in 1. Therefore we have x square plus y square minus 2xy is more than or equal to x square mod x square plus mod y square minus 2 times of mod x into mod y. Therefore, this side I get x minus y whole square is more than or equal to mod x minus mod y whole square, or mod of x minus y whole square is more than or equal to mod x minus mod y whole square. Taking positive square root on both sides, we get mod of x minus y is more than or equal to mod x minus mod y, and of course we take mod. Why? Because square root of a number is. Okay, please take this. Find as f of x is equal to 1 when x is more than 0, 0 when x is equal to 0, minus 1 when x is less than 0. So it generates only 3 numbers. When the input is positive real number, output is 1. When input is negative real number, output is minus 1. When x is equal to 0, output is 0. And it can be written as mod x by x when x is not equal to 0, 0 when x is equal to 0. How do we justify this donation? When x is positive, mod x is equal to x, x by x cancel, we get 1. When x is negative, mod x is positive, and here you get negative, positive by negative is negative. That means either it produces 1 or minus 1. That's why we use this notation. Okay, now, and denoted by SGN of x. Okay, now what is the graph of this function? SGN of x. SGN is sign. Why? Because it generates either positive 1 or negative 1. So positive, negative sign, that's it called sign function, or you can call it as signum function. Okay, now graph. The graph. I use this one to draw the graph. First of all, when x is greater than 0, 0 is not included. So here, let this height is equal to 1. This is the graph. This is x is equal to 1. And 0, this one. Next one, when x is less than 0, minus 1. So, this is the graph. And this dot also included in the graph. Please note this.